Hello and welcome to a new video of Mostly Engineering and another part of our Enigma build series. And as you probably already guessed, today I want to talk about the rotor design. So we have the rotor from our puzzle box over here, and in the computer on Fusion 360 you can see the 3D model of the replica version. And you can see the digit ring is a little bit different, but why? We discussed this in the last video. And as we are talking about digit ring, I want to start with the terminology I will use on the build, because I skipped this in the last video, and so let's do this now. So if we have the rotor over here, we will have, this is the upper side and this is the lower side, or front and back, however you want to call it. So we have the upper pin plate over here. Then we have the tooth ring, the finger ring. Here with the numbers we have our digit ring. With the notch in here, that's our curve ring, the lower pin plate, the sleeve, and then the clamp assembly. And it's also important to know with a rotor is where the A pin is. So if you see the screw here, then the pin, the screw, the number and the center forming one line, and the pin on this line is the A pin, and then we go clockwise B, C, D, and so on and so forth. And on the other side we see the pin, screw and center forming a line, and the A pin is opposite of this, and then that's the correct way up. The A pin is this one, and then we go counterclockwise B, C, D, and so on and so forth. And you see, depending on how you turn it over, it's very easy to accidentally flip the pin. So when you're modeling and doing this motion constantly, you have to keep this in mind. But let's talk about the design itself, where I was sticking to the plan and where I used a different design and for which reasons. So let's start with the centerpiece, like what kind of builds up the chassis of the rotor where everything else gets screwed into. So in the original design, this part would look like this, and here the spring-loaded pin would sit in. So, and let's go over to the computer again. Remove all the parts we don't need at the moment. It will just take a second. And we are left with the same part, what I call as the center column. And the first thing that springs into your eye is that the tooth ring is attached to this piece. And the reason for this is our two-piece design of the tooth ring and the finger ring. So this would be also on original machines with the same design. What is not on the original machines is when we turn the piece over. So you see now it's really a central column, and you also see why the original design was quite different, because with this geometry the only manufacturing method we can use is 3D printing, or split this part up in multiple parts. And 3D printing wasn't around at the time. So this design, I think, gives us several advantages. And the first one is to look at the original build. So then the central column would be this part over here, and the lower pin plate would rest on here. The central wheel, rotor, however you want to call it, would rest on here, and we have this space in between here for the wiring. With the new design, we would get a lot more place for the wiring, probably double the amount for the wiring. And I think it's fair to assume that if we have more space inside here for the wiring, the whole process will be a lot easier. Another advantage comes from the material side of things. Like, I want to build this part out of brass, and to manufacture this part we would have to turn all this material away here, or this material away, and this if we have the luck to find a tube with the right inside and outside diameter. What, looking at the numbers, is not very likely. So very likely we would have to use a round stock and also turn everything inside here away. And this is quite a lot of material that gets lost, and brass is expensive, so not the ideal way. And in the new design, we have the central column, and there we would just insert a brass tube and cut it to length, put some chamfers on the end so that it looks nice, and we are done with it. Much easier process, and we lose barely any material at all. So let's go back over the computer, and we see our part here. Now the lower pin plate will bolt into here, and then we can insert the pins with the wire and then push the wire to the right hole over here. And to make this process also easier, you see I added the ladders to each pinhole, and so we don't have to think about it like, okay, this is the A pin and now we have to go A, B, C, D, E, and so on and so forth until we find the right pin. So this will streamline the process probably by a lot. So when we build it up, so this will be screwed together, wired together. Then we will secure all of it with the upper pin plate. Then we would slide the fingering on, secured with these 4 screws over here, and also align it with these notches here. And what we also see is a different method in attaching the sleeve. So in the original drawing we have a big hole over here where a threaded insert would go, and here we will cut the thread in the sleeve and then screw the screw in, and the screw would stick out like a pin in a hole. So the hole is much smaller, so the whole area is much smaller, giving all this free space down here for the wiring again, and the screw would just work like a locating pin. Should be plenty enough to secure the part. And then we also have the slot over here to secure the sleeve in its desired position. Then we would push the digit ring over the sleeve, push the sleeve on the part. The sleeve also secures the fingering again, and then we would put the clamp holders on it. The clamp holders would also hold the digit ring down, put the curve ring on, and having all the pins in, and we have the ready rotor. So very nice. And let's take a look to the inside for a second. Make it a little bit bigger. And here you see is a big void we have for the wiring. So this is a big advantage of this design. And what you also see is that we have the pins from the lower pin plate and the inside pins. Between the inside pin and the outside pins here, there would be a spring pressing these pins apart against these parts, and therefore ensuring them in their position, and also ensuring connection, because we have a conductive metal here, then in touch with the spring, also made out of a conductive metal, and with this pin also made of conductive metal. So we ensure the electric connection here. And also very different from the original design is that these pins here and these pins here are exactly the same size. And this is a design choice to make the build a lot easier, because if you see, we have 26 pins over here, 26 pins over here. So in one rotor we would already need 52 pins. For a set of all 5 rotors we would already need 260 pins. So that's quite a lot of pins. I mean, it's a relatively simple part, don't get me wrong, but making all of them by hand in the precision we need would still take a lot of time. And a lot of time always is a lot of money. And therefore I will look to find someone with a CNC lathe. Someone with a CNC lathe probably can turn out these parts 4 cents a piece, considering even the high number of parts we need. And therefore I made the parts exactly the same. And again, it's in the inside. No one will ever see this, so historically accuracy is not the goal here. So that's basically my plan and how I want to construct the rotors. So for the next video I will have the CNC cut parts and the 3D printed parts, and we will probably start with manufacturing the sleeve and turning out some pins probably. Until then, if you have questions, comments, just let me know down below. And lastly, thanks for watching and see you at the next time. Bye bye.